if you've never been to the Spectrum lectures before, we always try to take advantage of the fortunate situation we have in this part of the state, in this part of the country, being so close to so many very talented research pools and research facilities, to bring in some speakers from the outside to talk to our students about the kind of things that happen in the science technology field outside of Montgomery College. And we are very fortunate today to have a very talented scientist that's been actually a Spectrum lecturer about 9-ish or so years ago. It's Dr. Michael Turell, and just a little bit on the background of our speaker today. Speaking to him earlier today, talking to him about all the traveling he's been doing the last couple of weeks. He's probably exhausted, so if he leans on the podium a lot, we'll understand because of his really, really busy schedule. But keeping that in mind, he is now retired, and I guess he's more busy now that he's retired than before he was retired. But he spent 30 years working at the U.S. Army Medical Research Institute for Infectious Diseases. He got his BS and his MS from Cornell in entomology. He got an MPH from Tulane and a PhD in epidemiology from UC Berkeley. His research focus over the course of his career has been on mosquitoes and mosquito-borne viruses. I guess those are called arboviruses. And that's what he's going to talk to us today about, are some of these viruses. He's done field studies throughout the world, including South America, Central America, Africa, East and Central Asia. He's worked on vaccines for some of these viruses and detection assays for some of these viruses. So he really does have a lot of experience in this area. Before I ask him up to talk to us today, I want to remind you of a couple of things. First, I know that a number of you are taking notes for classes, and in order to avoid a chorus of paper tearing at the end of the lecture, you should probably tear out that sheet of paper that you're taking notes on right now so we get the chorus of tearing done first. The second thing I want to remind you is you do not want to be that person whose cell phone goes off during the talk, so make sure it's the person sitting next to you and not you that everyone gets upset with, and shut off your cell phone now, please. The last thing I wanted to mention to you is, you may have seen this across campus, but it's the 70th anniversary of Montgomery College, and in order to celebrate that, they're doing various things throughout the campus, and one of the things they're doing is to help us celebrate Dr. Turell's presentation today, is there will be light refreshments after his talk at the back, not in the back of the hall, but just outside the hall where the table is. So I invite you to join the speaker there after his talk. So I've spoken way too long, so let me introduce Dr. Turell now, and let's give him a warm welcome. Thank
you. Thank you. First of all, I'm honored to be here and particularly be the first speaker this year. It's a pleasure to be back. I am retired, but that's sort of only in name. The lecture the talk I'm about to give was actually given a year and a half, almost, actually just over 2 years ago. Chikungunya, and I'll talk about in the talk, came into the Americas for the first time in the end of 2013. It has the exact same transmission cycle as Zika. When it first came in, it was first being transmitted in actually Caribbean and Central America. The people were really concerned that this virus might make it into the Americas and cause outbreaks. Does this sound familiar? By the way, if anybody has any questions at any time, please raise your hand. If we get too many questions, I'll put a stop to it. But if you have a question, I would much rather have you ask the question and try and answer it, because I'm sure if you've got a question, someone else has the same question. And rather than think about your question and not listen to me, ask the question. So I gave this lecture, or the basic part of this, in March, April of 2014. I've updated a little bit of some Zika stuff and some of the numbers since then, But basically, this talk was given right after the virus was first found in the Americas. That being said, as a former government employee, I always have my disclaimer slide up here, because some of these slides were produced when I was a government employee. Everything I'm saying is my own personal opinion and has absolutely nothing to do with the federal government. And I also want to thank Ann Powers of the CDC, who investigated the major chick outbreak that occurred in the islands around the Indian Ocean back 2005, 2007, and she graciously provided me a series of slides, which are some of the first slides I'm going to be showing in this talk. Before I start this again back to 2014, what happens when a new virus gets somewhere? Think 1999 West Nile. Virtually nobody in North America or South America had ever heard of West Nile virus. It made it into New York City sometime in the summer of 1999, had an outbreak in and around New York City in 1999, and then shortly thereafter, over the next 3 years, it spread completely across the United States, causing thousands upon thousands of human infections. And to this day, averages 2,500 human cases, not infections, human cases every year. Given the percent of infections that become actual cases, that's probably more than 10,000 infections. That's if every case was reported. And given reporting is so bad, I'm guessing there's probably 30 to 40,000 infections per year of West Nile in North America, in the United States. This is still a real problem. Okay, chikungunya, the topic of today. And for the most part, everything I'm saying about chikungunya, except for the clinical disease, you can change that to Zika. Everything else is identical. Okay, the primary symptoms. It's a febrile illness. You've got joint pain. Your muscles ache. Chikungunya actually means that which bends up. You're like this because you're in pain. And you can barely walk. You're in bed for a week. You are miserable. You often have a rash. You have retroorbital pain. You hurt, you're in pain, you're in agony, and the arthritis can last for months, in some cases years. It's not a nice disease. You get a rash, you get ankle swelling, knee swelling. Can we dim the lights a little bit so the slides show a little bit better? Can I get the front lights dimmed just a little bit? Well, maybe, maybe not. In any case, the big outbreak, well, the virus has been known for about 60 years. It's been around for a long time, caused a few sporadic outbreaks, but nothing really big until 2005. There was an outbreak in Kenya. It moved down the east coast of Africa and then moved into the islands in the Indian Ocean around South Africa and started a big outbreak. It then spread to India, Sri Lanka, and there were imported cases in the United States and throughout Europe of all the people vacationing on Comoros. La Réunion is a favorite place for French people to go visit where it's warm and sunny, particularly in the wintertime. There were about 500,000 people infected. I've actually heard more than 1 million people infected. Most of the islands actually had greater than a 50% attack rate. It means half of the people were known to be sick and infected. About 50% of the cases were hospitalized or stayed in bed for at least a week. About half of the people missed work. This was not a nice disease. This is the timeline, and I apologize for this slide because I was commenting about bad slides. This is a bad slide. I'm trying to show what happened. Started in April 2004. It spread across the various islands, and basically it ended in 2007. There is a key thing on this slide, and that is right here. There was a mutation in the virus that allowed this virus to be more efficiently transmitted by mosquito called Aedes albopictus. Aedes aegypti, like with Zika, is the primary vector. Aedes albopictus, the Asian tiger mosquito, which, by the way, is our principal biting annoying mosquito that almost everybody in this room has been bit by this summer, and is also a vector of Zika. is not normally a vector, but was the primary vector on many of these islands during this outbreak. This mutation, which occurred here, increased the ability of this mosquito to transmit the virus. And I can't tell you how many grants and how much publication of people put out. We need to study this mutation because this mutation caused the outbreak. Wait a second. The mutation occurred at the end of the outbreak. How could that mutation have caused the outbreak? The outbreak occurred, it was in a mosquito that's not the normal vector. So the virus was selected for that was even more efficient in that vector. The outbreak caused the mutation rather than the mutation causing the outbreak. But that's another question. Okay, chikungunya in the Americas. This is why I was asked to speak to the Mid-Atlantic Mosquito Control Association and the Maryland Vector Control Association in early 2014 after it was first introduced here. In December 2013, there were 2 laboratory-confirmed cases of chikungunya on St. Martin's on people who lived on St. Martin's and had not left the island. That's the critical part. There had been many, many cases of people who, in the United States, in Canada, throughout Europe, who had come home from travel to India, the islands in the Caribbean and the Indian Ocean, gotten sick and had chikungunya, but not local transmission. This was local transmission, and the first time local transmission had ever been demonstrated in the Americas. Well, first question is, okay, you threw a match in the forest and it started a fire. Well, is it going to burn out and be gone in 10 minutes? Or is it going to catch the underbrush? How many cases will there be? Where will it spread? Actually, that's really a little bit out of place because by February, there were 6,000 cases. About the time I gave this talk, there were 17,000 cases. The rest of the slide has been added since that talk. There's no question the match didn't just start a little fire, it started a forest fire. How big was the forest fire going to be? At this talk in March, April of 2014, I stood up in front of the group and said, you know, I'm guessing there will be 1 million cases within 2 years in the Americas somewhere, and a bunch of cases, but no big outbreaks of the US. You know, onesies and outbreaks of onesies and twosies in the United States, but virtually nothing in the United States. As people who are going to get the phone calls, I said, but an outbreak of 1 case is going to make headlines because, oh my God, it's here. It's like a few years ago, there was a case of malaria in Virginia, and they went nuts. There's 1 or 2 cases of malaria locally transmitted in the United States every year. There's 1,500 imported cases every year, but only 1 or 2. The local case that year, actually there were 2 of them in Loudoun County, and they went nuts. It's not going to be sustained. We don't have the human mosquito contact anymore that we need. So I predicted more than 1 million cases within 2 years and a few scattered local cases. Earlier this year, I was at a meeting. Someone came up to me who was at that meeting 2 years ago and said, Mike, you were right. I said, no, I was wrong. It didn't take 2 years. There was more than 1 million cases the first year. It was worse than I thought. And that's reported cases. That's not actual cases. I know areas in Mexico where there were thousands of cases and nothing reported. So probably well over 2 million cases the first year. Updated data as of last week, there were just over 1 million cases in 2014, about half as many in 2015, and probably 1/3 as many in 2016. The numbers are going down because the susceptibles are going down. Again, think of my forest fire analogy. You throw a match into the forest. No, there hasn't been a fire there in 50 years. There's all this down wood. You get this tremendous blaze and everything catches. Then next year, you throw another match in there. It might or might not start anything, but if it starts, there's not as much down wood. And by the 3rd or 4th year, it fizzles. So that's what's basically happening here. Okay, I want to talk a little bit about an anthroponosis versus a zoonosis. And anthroponosis is a disease where the source of infection is a human. So this is something that goes human, mosquito, human, mosquito. For example, malaria is an anthroponosis. The only animals that get human malaria are humans and a few non-human primates. There's also bird malaria, but it's a completely different pathogen, completely different disease, completely different vectors. We can't get bird malaria, and they can't get human malaria. Dengue, chikungunya, Zika are 3 viruses that are anthroponoses, and filariasis is another anthroponosis. There are no non-human, other than non-human primates, non-human hosts for these. We are the source of infection. In contrast, a zoonosis is a disease where animals other than humans or non-human primates are the source of infection. For example, West Nile. Birds are the primary source of infection. The normal cycle is bird, mosquito, bird, mosquito, bird, mosquito, and every once in a while that mosquito bites a horse or a person, and the horse or the person gets infected, gets sick, may or may not die, but both the horse and the human are a dead end as far as the virus is concerned, because the virus does not produce a viremia, virus in the blood, in a mammal, which means that if a horse or a human gets infected, the animal may get sick, but the virus is dead because it can't go anywhere. There's eastern equine encephalitis, again, birds, St. Louis birds, Rift Valley fever, which is the virus I'm most concerned about, and that's cattle, goats, and sheep. And you can read the rest. Oh, notice on my list, not here, sorry about that. Okay, for a virus, I work with arboviruses. These are viruses transmitted by an arthropod. In my case, it's viruses and mosquitoes rather than viruses and ticks. In order for the transmission to occur, you have to have the pathogen. If there's no virus, you can have all the vectors, all the susceptibles you want. You can have all the dead trees and all the oxygen you want, but if you don't have a source of heat, nothing happens. The vectors, you need to have the pathogen, you need to have the vector, and you need to have a susceptible host. Today, my analogy seems to be fires. For fires, you have to have oxygen, a combustible source, and heat. You take away any one of the 3, the fire goes out. You take away any one of these 3, the virus does not get transmitted. And interacting with these 3 is environment. There are various environmental factors that affect whether or not the transmission is going to be efficient or inefficient. So I mentioned a little bit before about Aedes albopictus versus Aedes aegypti. These are the 2 most important. Aedes aegypti, as far as viruses go, is the most important virus vector in the world. It's the primary vector for yellow fever, for dengue, for chikungunya, and for Zika. Virtually all cases that occur for any one of those 4 diseases in humans is Aedes aegypti transmitted. Aedes albopictus was involved in part of the outbreak in that big chikungunya outbreak back on the islands of the Indian Ocean. I'll mention this again later, but I'm going to mention it now too. Just Aedes, yellow fever. Has yellow fever ever been? Yellow fever is a tropical disease. Well, just raise it. Who's heard of yellow fever? Yeah, good. This is a tropical disease. Has yellow fever ever been a real problem in Maryland or New York? I mean, not a case, I mean hundreds of cases. Yes or no? Yellow fever in the United States is the reason the Capitol is currently in Washington, D.C. In 1793, Philadelphia was the capital of the United States. There was an outbreak of yellow fever in Philadelphia, back in the mini ice age, I might add, that killed 5,000 people. There were about 25,000 cases of yellow fever in one summer in Philadelphia. Think of the population of Philadelphia in 1793. This was a the government fled Philadelphia, fled up to New York, and then down to Washington, D.C. because of yellow fever. There were major outbreaks in New York City. There were major outbreaks in Boston. This tropical disease caused outbreaks of thousands of deaths north of New York City. It's not a tropical disease. It is today because of sociological conditions, not because of temperature. Okay, back to aegypti versus albopictus. I mentioned that mutation. The methods used to control Aedes aegypti have been known. A short digression. In 1901, Walter Reed proved that Aedes aegypti was the mosquito that actually transmitted yellow fever. It was not contact with other cases. It was a mosquito-transmitted disease, where the pathogen that caused yellow fever is transmitted by a mosquito, and not just a mosquito, Aedes aegypti. Aedes aegypti lives in and around houses. It's actually very easy to control. And they started a commission, the Gorgas Commission, to basically go into Cuba and then Panama Canal, and they controlled aegypti, and they virtually eradicated yellow fever within a couple of years. You cut the mosquito population back, the virus disappeared. The methods used to control chikungunya, yellow fever, dengue, and Zika are all identical. We know exactly what to do. The problem is getting people to do it. I'll cover that again in a few minutes. Okay, I mentioned that thing about that mutation making the albopictus a much more competent vector, and all these papers that came out saying it was this mutation that allowed for this outbreak. We were doing a study on a chikungunya vaccine 15 years before the outbreak. And in order to, one of the questions the FDA had was, if you've got this live chikungunya virus vaccine, is it possible for a mosquito to become infected by biting a vaccinee, for the virus to mutate in that mosquito back to the parent nasty virus, and then start an outbreak? So we had to do the safety testing on it. Now, it'd be really easy for me to use, say, Culex pipiens, which you can't infect with the virus at all, infect the monkey with the vaccine, feed Culex pipiens on it, and say, it doesn't get infected. The vaccine is safe. So it's dishonest, but that's done in pharmaceutical companies. So what I did, I took a whole bunch of mosquitoes, about 20 different strains of mosquitoes that I suspected as being good vectors, infected a monkey of chikungunya, fed all the mosquitoes on it to find out which was the best mosquito, or from the human perspective, which was the worst mosquito, i.e., the one that was the best vector. That's the one we use in the safety testing, because if we can't infect that one, we're not infecting anybody. If you look at this, look at the infection rates in the various albopictus, look at the infection rates in the various aegypti. The least susceptible aegypti, the worst one of them all, was still slightly more susceptible than the best aegypti. Albopictus always has been and always will be a more competent vector than Aedes aegypti. The difference is that aegypti likes people. This is a mosquito that has adapted to people for hundreds and hundreds of years. It's a person mosquito. And by the example I gave talking to people, if you took a barn, and in this barn you put some horses, cows, pigs, chickens, frogs, turtles, and a couple of people, and you released some albopictus in there, they're going to go to the closest animal they can find. They like blood. They don't really care. They prefer a mammal, but if the closest thing is a bird, they'll feed on the bird. They'll feed on anything. You let aegypti in that room, I don't care where the person is hiding, the mosquito will find the person. It likes people. It will selectively find the person, which makes it a much, much more dangerous vector for an anthroponosis, because in order to transmit the virus, the mosquito needs to feed first on a person with the virus, and then incubate, become infected, incubate it, get the virus through its body, and then able to transmit, and then transmit it to another person. If you get an albopictus, if it feeds in a person with the virus and gets infected, it's most likely to feed on a frog or a cow or a dog or a pig next. And none of those animals will develop Zika or Chikungunya. So the virus goes nowhere. It has to feed repeatedly on a person. On the islands in the Indian Ocean, there were lots and lots of people and almost no local animals for the mosquitoes to feed on. So on those islands, the albopictus were really efficient because they're more efficient vectors in the laboratory, they're more competent, but their vectorial capacity is much lower because they feed on anything. But given no choice, they fed on the people. And boy, were they good vectors. Okay. I think people are probably more interested in Chikungunya than, Zika than Chikungunya, I put some data here on, that just came out this year on the ability of mosquitoes to transmit Zika virus. And as with Chikungunya, Aedes aegypti, Aedes albopictus, terribly small numbers, were about 1/4 of them transmitted virus by bite. So if you fed on an animal that was infectious, i.e. a person, about 1/4 of them would go on to actually transmit the virus by bite. There's been a lot of talk in the news recently about Culex mosquitoes as potential vectors. You're more likely to get bit by a Culex mosquito than an Aedes mosquito, bigger numbers, more bites. The fact that you get lots and lots of bites from a Culex doesn't mean anything. And in order to transmit this virus, the mosquito has to feed twice on a human. If you have 20 times as many Culex mosquitoes out there, and you get twice as many bites, those mosquitoes are feeding primarily on birds. So it's going to be bird-human or human-bird, and unlikely to get a third blood meal. Extremely unlikely to transmit an anthroponosis, and extremely dangerous for a zoonosis such as, in this case, West Nile virus. It does not get infected with Eastern equine, so it doesn't transmit Eastern, but it does transmit a bunch of other viruses. St. Louis encephalitis, West Nile virus, are transmitted by the local Culex mosquito, so they are dangerous for that virus, but not for Zika. And this one, 0 out of 50, I mean, 50 was, there's a paper which I just accepted for publication last week that looked at 3 other species of Culex with essentially identical results. Same sample size, high viremias, and you could not infect them. I think they had 1 out of 200 mosquitoes infected, and that one, the virus was only in the gut, transmission was 0. So Culex, 1, are incompetent, and 2, even if they were efficient laboratory vectors, their feeding behavior means they would not be involved. I was at a meeting 2 weeks ago in Orlando where this woman passionately was saying, no one's, from Brazil, no one is looking at Culex. Culex have got to be important. We have so many Culex mosquitoes and so much Zika, and the mosquitoes bite people, and no one is looking at them, and we need to look at the Culex. I'm sitting there cringing because epidemiologically, they're not involved. And she's trying to divert money from aegypti control to Culex control, which might be important for other diseases, but not for Zika. Okay. Remember, this talk was given in March, April of 2014, and my question was, what other viruses might be coming into the Americas? What would I be concerned about? Well, I never thought of Zika. I did think of Rift Valley fever, which is a virus I mentioned earlier. It's a virus of cattle, goats, and sheep. It's an African virus. It's a devastating virus. Young animals virtually always die. Pregnant animals virtually always abort. This is a zoonosis rather than anthroponosis. So you have mosquitoes that feed on horses, cattle, goats, and sheep, get infected, and then bite people. And by the way, unlike West Nile, if humans get infected with this virus, humans have a viremia of 10 to the 8th. That's 100 million virus particles per ml of blood. Maybe 10 to the 9th, almost 1 billion virus particles per ml. It is unbelievably high viremia, more than 100-fold higher than the amount needed to infect mosquitoes. So humans are an amplifying host that can spread this virus. That's a scary virus. Japanese encephalitis. There's a group of viruses called the Japanese encephalitis virus group. One of those viruses, called St. Louis encephalitis, used to be the most common virus in North America. More cases of St. Louis encephalitis than any other arbovirus. Most infections are fairly mild. It's basically only the elderly that got seriously ill, and there were a couple of deaths every several years from St. Louis encephalitis. Not a particularly bad virus. Its evil stepsister, called West Nile, another member of the same group, with almost the identical transmission cycle, came to the Americas in 1999. And the evil stepsister is much, much worse, averaging 2,500 cases a year reported and hundreds of deaths every year. This is a bad virus. Of course, the evil stepsister doesn't even compare to the evil stepmother, which is Japanese encephalitis. Japanese encephalitis currently causes about 10,000 deaths every year in the world, which is actually surprising and amazing because it's a good vaccine that completely prevents it. Countries like Korea, excuse me a second, used to have hundreds, if not thousands, of deaths from JE every single year. I'm guessing it was about, I should look up the date, about 25 years ago, they came up with a vaccine. There might be 1 or 2 deaths from Japanese encephalitis in Korea every year now. Like we give measles, mumps, rubella to every kid, they give Japanese encephalitis vaccine to every single kid at a really young age. And there is virtually no infections in the country, except for diplomats and visitors, because we don't get vaccinated. Well, I do, but that's besides the point. So virtually all the cases in most of China, parts of Thailand are well vaccinated. India, thousands of deaths every year. There's no money for vaccine. There are thousands of deaths every year from Japanese encephalitis. Right now, we have 300 million people in this country. I'm guessing a couple of hundred of us are vaccinated. That's not a couple hundred million, that's a couple hundred total. That still leaves 300 million susceptibles out there. We have the birds, we have the mosquito vectors. This virus could go crazy here. So JE is a virus I'm concerned about. If it got here, the good news is, let me rephrase it. If my wife went to Thailand and got infected with JE and came home, got infected, bit by a mosquito the last day and came home and developed the infection here, she might get sick, she might die, but she won't be infectious to a mosquito because like West Nile, the virus does not produce a high titer. So it's a dead end. West Nile virus almost certainly flew into this country in an airplane as a mosquito. I did a lot of work in Peru, and it was really interesting that in the old airport in Lima, you take the 11 o'clock flight at night into Miami. Excuse me. It's an allergic cough, and it's very annoying. I apologize. But at 10 o'clock at night, it's one of those great big, 9 passengers across planes. 300, 400 people get out of the terminal and walk across the tarmac. They had the plane out on the runway with 4 sets of stairs going up. It is the most efficient way to get on the plane you've ever seen because you walk on the plane right by your seat. You go up the proper staircase, sit down, and it takes off. Of course, there's this cloud of mosquitoes right up above us. And I'm always watching the mosquitoes because that's me. And I get on the plane. I've killed 4 mosquitoes on one flight. I was able to kill 4 mosquitoes on one flight. This is a big plane. I don't think I touched the population of mosquitoes on that plane. But I killed 4 of them. I don't know how many thousand mosquitoes fly into the United States. There are people who actually study this, but it's thousands of mosquitoes every day fly in. The odds of one of those mosquitoes being infected or infectious, it's like winning the lottery. Or, in New York's case, losing the lottery. They won or lost, depending on your perspective, the West Nile lottery. Japanese encephalitis would come exactly the same way. The advantage is JE is not, any major airport area is not likely to have any JE in the area. You got more rural areas, you're more likely to get infected. People who are traveling from Asia to the United States are not as likely to get bit by a mosquito infected with JE virus. In Korea, I said there's virtually no cases, virtually none. If I went to Korea today, I would bet money that within 3 days, I could get a JE isolate from mosquito. I worked with a person in South Korea up on the DMZ, catching mosquitoes, testing mosquitoes for virus. And I think we got 15 or 16 isolations of Japanese encephalitis virus from the field collected mosquitoes, collected September, October. So we're right about the end of the season right now, but I can still get them today. 2 weeks from now, it'd be too cold. 2 weeks ago would have been better. But this is still the time of year, if you go out there, there's a real risk of getting infected. But the people who are out there, where the mosquitoes are not likely to get on an airplane the next day. And, well, the mosquito is not likely to get from there to an airport and get on the plane. West Nile is a little bit closer to the airports. Rift, the scenario that I usually have is, my wife and I are going on safari in Kenya. It's really cool. We got to see all kinds of cool animals earlier this year. On our last day on safari, my wife got bit by a mosquito. She came home. She felt miserable for 3 days. It's jet lag because it's a 24-hour flight to get home. It wasn't jet lag. It was Rift Valley fever. No, she may or may not have been bit by any mosquitoes. I don't think she was. But no, she did not get infected. But that is the scenario. You have a dairy farmer out of Texas who goes on safari and comes home, infects his herd, and the rest is, as we say, history. Well, what needs to be done? In many ways, West Nile was a really, really good thing. That prior to West Nile coming here, we have done such a good job in controlling mosquitoes. Digress for a second. If you go back into 1950s and 60s and 40s, mosquitoes were a real problem. If someone said, we want to have a small tax of $2 a person for mosquito control, the vote would have been 95-5 in favor. Kill the darn things. We don't want mosquitoes. Because they did such a good job killing them, people don't understand how bad mosquitoes are anymore. Therefore, it's gotten harder and harder to get funding to do mosquito control. You add to that the environmentalist movement, the resistance of mosquitoes to pesticides, the no-fly zones of, you can't use pesticides within 100 yards of my property. When West Nile virus hit New York City, there were people suing the government because they were spraying for mosquitoes within 100 yards of their house. And there were people suing the government because they were not spraying their house. They got two next-door neighbors. They both sued the government. One because they sprayed, one because they didn't spray. I don't understand it, but that's one of the problems. Okay. West Nile brought this to attention and greatly improved mosquito control. But as time is going on, we become complacent again, and Zika has done a really good job of enhancing our awareness that these diseases are out there. Public education. We need to understand that mosquitoes are not just a nasty, annoying nuisance. They can transmit disease. During the US Civil War, amongst soldiers, there were 1.3 million cases of malaria. This tropical disease caused 1.3 million cases in US soldiers in the 1860s. It's not so much a tropical disease as a disease of human-mosquito contact. Aegypti, if you look at the United States of 1793 or 1825, you don't have running water, you don't have electricity. When you have water in your household, you send the kids down to the stream or down to the well, you fill up a bunch of buckets of water, you carry them back to your house, you dump them in the storage tank that you have for water, and that's the water that you use, and that's the water that Aedes aegypti live in. Once you have piped water, you don't have all these water storage tanks all over the place. You have piped water. And the mosquitoes, your population just plummets. At the same time, try and find a house in the United States that doesn't have doors and screening on it. Try to find a house in Peru, in any village, that has screening. Most houses in the tropics have bars on the windows. If it's a real house, it will have bars on the windows to keep human pests out. But there's no screening on the window to keep the mosquitoes out. So mosquitoes come in and out. There's containers holding water all over the place. And that's why we have tremendous outbreaks of dengue, chikungunya, and Zika throughout the Central America, South America, Caribbean islands. And why we had similar outbreaks in the United States in the 17 and early 1800s. Near the end of the 19th century, we started putting screening on houses. We started getting piped water, and all that went away. The conditions of much of South and Central America is really not any different than the United States of the early 1800s as far as housing is concerned. And that's what allows Aedes aegypti to persist. You take a little plastic container, holds half a cup of water, that's 100 mosquitoes. And the mosquitoes will find it. So I know my next door, my best friend went over to her house the other night. She's got, on her back porch, she has these great big flower pots in these plastic things. And I took a look in one. She had over 1,000 Aedes albopictus larvae on her back porch. It just started to pupate. Within 4 days, she would have had 1,000 biting albopictus on her porch. She would have been eaten alive by these things. And those will go for people there because that's where she is. It's a very simple solution. You take the pot, you move it over, you take the water, you dump it out, you put the pot back in there. You do that once a week, and it's gone. One of the problems we have in the modern world is we have plastic containers. You throw this in your backyard, and it constantly produces mosquitoes, tires, bird baths. Any of these containers will produce Aedes aegypti or Aedes albopictus. Warmer climates, it's both. Here, it's going to be Aedes albopictus. How do you get the public to go in its backyard and drain? Well, I've spent a lot of time in South America finding coconut husks in someone's backyard filled with mosquito larvae. And you show it to them and say, yeah. And they say, those are mosquitoes. No, those aren't mosquitoes. Those are worms. Those are mosquitoes. No, mosquitoes fly and bite. You don't know anything. Public education. We need to have people understand where do mosquitoes come from. A mosquito is not a mosquito. There are more than 3,500 different kinds of mosquitoes. In the United States, we really have one species of mosquito to really worry about Zika, and that's Aedes aegypti. And albopictus is of some concern. And you can virtually forget all the others. So when you're doing mosquito, another short digression. When West Nile virus got here, they canceled all the Friday night football games and moved them to Saturday afternoon, which was actually a good thing because the mosquito that transmits West Nile is a nighttime biter. And having crowds of people all together in the stands was a risky activity. The mosquito that transmits Zika is a daytime biter. I could just see if they had an outbreak here, they canceled the Friday night football games to make them Saturday afternoon games, which is the worst thing you could do for this virus. You got to make the Saturday afternoon things into Friday night things. Knowing which mosquito transmits it allows you to control the proper mosquito. And my work for almost 40 years was trying to find out which mosquito transmits which virus and what factors make it more or less likely for that mosquito to transmit that virus, so that the mosquito control people could then target the appropriate control people are really good. They can control any mosquito, given public cooperation. They know exactly what to do. but the methods to control species A may have no impact whatsoever on species B. So you have to tell them, for this disease, control the Culex pipiens. For this disease, control the albopictus. For that disease, control the Anopheles punctopenis. So different mosquitoes for different diseases. Controlling the malaria vectors will do nothing for West Nile or Zika. Controlling the Zika vectors will do nothing for West Nile or malaria. You have to control the right mosquito. Better diagnostics. With all of the problems with Zika, I don't think there are any good diagnostics for Zika. Zika virus is a flavivirus. It's somewhat related to dengue, yellow fever, West Nile, St. Louis encephalitis. And if you've had dengue or St. Louis or West Nile, and they test you with a standard test for Zika, it will be positive, even though you've never had it. So how many cases of Zika were really West Nile, dengue, yellow fever vaccine? Who knows? We need a better diagnostic assay. And with that, I want to show a little bit of stuff. This is how many countries actually had, by the way, the first country with Zika was not Brazil, it was Chile. The second country was Brazil. And I think there are now 45 or 46 countries in the Americas that have had proven Zika transmission, with not imported cases, transmission within the country. As of last week, there have now been 128 locally acquired cases, and I'm not well convinced that all 128 of those are Zika, but they're positive on a Zika assay. I'm assuming that the CDC says that they're Zika. They probably are Zika, but I'm still not convinced. There's been one laboratory infection and more than 3,800 imported cases for a total of almost 4,000 cases of Zika have been diagnosed inside the continental United States. But outside of southern Florida, there's not been a single case, not one case, that is locally transmitted by a mosquito. And unlike many of the other viruses, Zika virus is an STD. Primarily male to female, but there has been demonstrated female to male. It can be sexually transmitted. The big issue with Zika is obviously microcephaly, which is a major birth defect. It's still a bit iffy as to what % of infections will actually result in microcephaly. And it's a real short digression. Brazil is not known for its health reporting system. How many cases of microcephaly were occurring every month and nobody reported them? All of a sudden, it makes international news that Zika causes microcephaly. Every physician in the country is reporting every suspected case of microcephaly, and the number of cases goes up multiple folds. Was there really any increase in cases at all or not? I don't know. I'm assuming that there was. But reporting is much more important than actual cases being there. So we don't really know what's happened with those. This is the map showing where outbreak of where yellow fever used to occur in the United States. Up to New Hampshire. These are all not onesies, and these are outbreaks of hundreds of cases in a single year. More than 100,000 deaths, and some stuff I've read yesterday, there were more than 40,000 deaths in New Orleans alone. In New Orleans alone, there were more than 40,000 recorded deaths from yellow fever. This is a virus that, and the reason there was no United States beyond here when this virus was still being transmitted. This virus came in with sailors on sailing ship. The aegypti came in with sailing ships. We don't have the sailing ship back and forth to the Caribbean anymore. We do have container ships, though, which bring in these big containers filled with God knows what, and they open the containers, the mosquitoes fly out, and people fly in back and forth from the Caribbean on airplanes, which is actually so much more efficient than sailing ships. So I'm actually sort of surprised we haven't had more of this. With that, thank you. Are there any questions? What time is it? I think. Yep. I got a question. Let me try. Okay, the question is, why is the United States so parochial and does not care about a disease that is not found in the United States and doesn't worry about that disease until it gets here? I've been working for 40 years trying, to me, the best way to fight a disease from coming to the United States is to put the fire out in the country where the fire is currently existing. If you put the fire out there, it won't spread here. So if you can control the disease, control the mosquito in Brazil, Central America, Africa, Asia, wherever, then it's much less likely for that virus or that pathogen to come to the United States and cause it's money. And despite the comment, and I worked for the Army for close to 40 years. The Army has soldiers all over the place. Up until very recently, many more soldiers died from from diseases than from enemy action. Historically, diseases are the Army's, and that's any army, worst enemy, not acute lead poisoning. Acute lead poisoning is a small percent of the deaths. It's disease. So the Army has spent millions upon millions of dollars trying to stop these diseases all over the world. Other questions?
If you could come to the microphone and ask
There's a microphone over there.
so they can capture it for the video that we're making. So we'd appreciate it if you have a question. If you could walk up to the microphone and ask it.
Way in the back.
Yes, please.
As he's walking up, does anybody else have a question? We'll wait about 15 seconds.
Actually, I have a question.
Sure.
You mentioned that the Egyptian mosquito prefers people.
Yes. Oh,
Is there a preference between people that they prefer some people more than others?
the question is basically, do mosquitoes feed randomly on people or are some people more attractive? Everybody knows that they get bit like crazy and their spouse does not. It's always amazing. Everyone I talk to is they get bit and their significant other does not. It's not their significant other gets bit and they don't. Two things. One, there is some truth to that, but it's not all what it seems to be. I spent a lot of time in South America. I have watched people with 3, 4 mosquitoes biting their face, and they don't even know it. They are so used to mosquito bites that being bit 3, 4 mosquitoes feeding on their face, there are no mosquitoes here. They don't notice them. If someone else is there and they're getting 1 bite every hour, the mosquitoes are terrible, and they're getting 2 bites a minute. It's part of this is reaction. People who react to bites, quote, get more bites because it's reporting. It's not number of bites actually occurring. So if you react to the bites, you obviously get more bites than someone else who doesn't react to the bites. And various studies have shown that if you put 3 people in the same room, some people get more bites and some people get less bites. But some of the people who think they're getting more bites are actually getting less bites. So it's a very complicated question. Yes? Say again? The difference in the infection bites for the albopictus and the aegypti. Okay, that study was actually done about 1988, 1989, I think. Published about 1992. Where the outbreak, where the mutation occurred was 2006, I think. So this is almost 20 years before that. In the study, we're looking at the albopictus, the aegypti. I took a monkey, I infected with Chikungunya virus, waited a day, I anesthetized the monkey, had 20 little pint cartons filled with mosquitoes, put them out on the table, and laid that poor monkey unconscious on top of 20 cartons of mosquitoes and let them feed. So that all the mosquitoes were exposed to exactly the same dose of virus at exactly the same time, and fed on a viremic animal, not on what's done today of you take some blood, you take some virus, you mix them together, you get a hematech feeder, and you feed mosquitoes on the stuff that a mosquito will never see in the real world. Was that the question? Okay. Other questions? Yes? Okay. I think that, I assume everybody, well, I always repeat questions, so in addition to removing plastic containers or any container that can hold water, what else can be done? Depends on the mosquito you're trying to get rid of. If you're talking of aegypti, albopictus, possibly japonicus, these are small container breeders. I mean, a bottle cap of water. People have actually found mosquitoes. You may get 10 mosquitoes living in one bottle cap. They're really adapted to human waste products or human garbage products. Big thing for the albopictus and the aegypti, any container that can hold water, turn it upside down, or if it's a bird bath that you have water in, not a problem. The larvae take about 7 days to go from the egg stage to the adult stage. Once a week, take a hose and just hose it out or dump the water out. If you dump them on the grass, every one of those larvae will die. So once a week, empty the water out. If you're talking of Culex mosquitoes, they do really, really well in abandoned swimming pools. You're not going to find the aegypti in there, but you will find the Culex pipiens, the West Nile vector. If you've got an abandoned pool, drain it, cover it, treat it. But you have to, they like sewage treatment plant water. They like water in a, not as much a stream, but in a culvert in the side of the road. Other mosquitoes like hoof prints in a marsh. Those are really great because if you have a pond or a lake, you look at all that water, that's fantastic. Not for the mosquito. Because in that water you have tadpoles and all kinds of other insects that feed on mosquito larvae. So if mosquitoes lay eggs there, they are at the bottom of the food chain and they are providing food for somebody else. If they lay their eggs in a small container that has no tadpoles, no fish, no other insects in there, they're at the top of the food chain because they're feeding on people. Same mosquito. The mosquitoes that laid their eggs in that pond disappeared about 1 million years ago because none of them survived. The ones that laid their eggs in the footprint or in the container, those are the ones that are still with us. Screening is important. Repellent is important. If I'm traveling, I always have repellent with me. I tend not to put repellent on. I'm saying this personally, I tend not. My wife always does, I never do. If I don't see a mosquito, I don't wear repellent. I see a mosquito, I forget being bit. I see a mosquito, repellent comes on, but not until I actually see the mosquitoes. So repellent can be particularly important for kids, long sleeve shirts, lightweight long sleeve, things that reduce mosquito contact, so personal protective equipment, i.e. appropriate clothing, repellent, screening on housing, making sure there is no standing water anywhere near your house, probably the biggest things. Other questions? I think we're getting close to time. If someone has a question, I get free food. So I will be at the food table. Come find me.